consider the following restriction. So let us work on the interval. So let I be an interval. Okay. And suppose that f, let f is a function with the domain is a interval. Okay. Let's say, and we may consider the, let's say, the union of the interval as well, and also we may impose some assumption on the interval. For example, if we consider the interval is closed and bounded interval, and then we also use the continuity for the function on the interval as well. Okay, so let us first discuss the definition of the maximum value or the minimum value. Okay, so let us consider, let's say, the maximum value first, and then the minimum value. Okay. So the value f of c is called the minimum value, the maximum value of f on the, let's say, the interval I or any set I, if fc is the largest value of f on the interval I. For example, precisely fc is always greater than or equal to f of x for all x in the interval I, for example. Okay, so that's the definition of the maximum value. And then the definition of the minimum value is similar. Okay. And of course, the value, the point C here is called the maximum point. Okay. So the value of FC is called the maximum value. And if it attains at C, then C is called the maximum point. Okay. So in this case, let us consider the minimum value. So in this case, FC is called the the minimum value if the value of FC is the smallest one, namely FC is less than or equal to f of x for all x in the interval I. So that's the meaning of the maximum and the minimum value. Okay. So if, okay, so this is the definition. So if FC is a maximum value or a minimum value, then f of c is called an extreme value. So if fc is either a maximum value or a minimum value, then we call fc as extreme value. Okay. So the problem to find the maxima and minima can be abbreviated by finding the extreme value or the extreme point. Okay. So let us take a look at the following example. Okay, so let us take a look at the example for the maximum and minimum value by graph. Okay, so let us take a look at the maximum and minimum value by the graph. Okay, for example, if I consider y equals to x squared here, and then I is the interval is the whole real line, then what is the minimum value of y equals to f of x equals to x squared? What is the minimum value? y equals to f of x equals to x squared, the minimum value is 0, right? So the reason is that the value of f0 is 0, and 0 is obviously is less than or equal to x squared for any real number x. So the square of every real number is always non-negative. So here we have f of x. So the minimum value of f is 0. Okay, so what is the maximum value of this function? The maximum value does not exist because the function is unbounded. So you see that if you have a certain number, then you may always find x such that f of x is greater than that chosen number, right? For example, if you are given, let's say, a number equals to 10, for example, okay, then you may still find x such that f of x is greater than 10. If you choose the number 1000, then you may choose x so that x squared is always greater than 1000 and so forth. So the uh, the thing is f of x equals to x squared is unbounded above. So f of x does not have a maximum value. Yeah. So the maximum value does not exist, and the minimum value is 0. Okay. So in this conclusion. Okay. All right. Any question or comment? All right. Okay. So let us continue. So suppose that now I will replace here y equals to x squared by, let's say, y equals to minus x squared. In this case, you'll see that the maximum value is 0 and the minimum value does not exist. Okay. So the maximum value of f of x equals to minus x squared is 0, and namely at f0, and the minimum value or the function f of x equals to minus x squared does not have the minimum value because it's unbounded below. Okay, so you'll see that if we are given, let's say, minus 15, for example, we can find x such that minus x squared is always less than minus 15. If we are given minus a million, then you may find x such that, for example, x equals to 1001, then x squared is less than minus x squared is always less than minus a million, for example. So this does not have a minimum value. Okay. All right. Any question or comment? So of course, if you consider, let's say, sine x, for example, or y equals to sine x, so you'll see that what is the maximum value? The maximum value is 1, and the minimum value is minus 1. Okay, okay. And then the maximum value can be attained at infinitely many number. Let's say pi over 2, 5 pi over 2, minus 3 pi over 2, and so forth. And the minimum value is attained at minus pi over 2, 3 pi over 2, 7 pi over 2, and so forth. So this function, so if f of x equals to sine of x, f of x equals to sine of x, then the maximum value of f is 1, and the minimum value of f is -1. Okay. All right. Any question or comment? Okay. So the next one, we may also check the maximum value or the minimum value of the function, but only at a certain interval. For example, if I consider y equals to absolute value of x, for example, okay, in this case, of course, okay, you may consider this for all real number, but you'll see that for all real number, it only have the minimum value only, because once again it's unbounded for any uh, real number. But if we concentrate on, let's say, the interval, let's say -4 until let's say, if we concentrate from the interval -4 until 2, you'll see that we only concentrate on the graph of this function, only in this part of the graph. And you'll see that here, what is the, if I restrict the function into the interval, the closed and bounded interval -4 until 2, then you'll see that the function have maximum value and the minimum value. So if I start with f of x, so let f of x equals to absolute value of x, but we only concentrate for every x in the interval -4 until 2, okay, then you'll see that the minimum value, of f on the interval -4, 2 is, again, is 0, f0, okay. But you'll see that the maximum value, what is the maximum value? The maximum value is 4, right? The maximum value of fx equals to absolute value of x on the interval -4, 2 is f -4, sorry, and that will be equals to absolute value of -4 is 4. Okay. So you see that from the picture, you'll see is the highest point on the curve there, -4, 4. Okay. So in this case, if we concentrate on the continuous function on the closed and bounded interval, we always guarantee the existence of the maximum value and the minimum value. Okay. So now let us concentrate on the function f. Okay, let's say, and the function f is continuous on the closed and bounded interval a comma b. Okay. Okay, so I will save it and then go back to the whiteboard. Okay, so uh, now assume that f is continuous on the closed and bounded interval a comma b, let's say. So this is the key point. Okay, so I will write incomplete and the closed and bounded interval a comma b. Okay, so the key point here is the word continuity and then the closed and bounded interval. Okay. In this case, then with this assumption, then f always have the maximum, always have a maximum or a minimum value, or always have an extreme value. Okay. Okay. So now let us take a look at the position of the location of the maximum point or the minimum point. Okay, so now let us focus on the function f. where the function f is continuous on the closed and bounded interval. Okay, but now the question is, where is the maximum or where is the minimum value attained? Okay, so in the previous picture, okay, in the previous picture here, okay, you'll see that if I concentrate on the interval -4 until 2, you'll see that the maximum is attained at -4, namely the boundary point. And then the minimum is attained at this point, at 0. And if I take a look at another example, y equals to x squared here, and then I want to restrict, let's say, on the interval -2 until 1, for example. Once again, the maximum value is attained at the endpoint of the interval, and then the minimum point is here in this case. So you'll see that the difference here, if you consider the point x equals to 0, so you'll see that the gradient, okay, the gradient of the tangent line here is 0, right? So in this case, you will see that we have the gradient of the tangent line is 0. And note that the gradient of the tangent line to the curve is just the derivative of the function at the point. Okay? And you'll see that the derivative of x squared is 2x, and 0, 2 times 0 is 0. Okay? So if I combine this with this observation, namely this observation, you'll see that on the other hand, at this point, at 0, you'll see that if I consider y equals to f of x equals to absolute value of x, at 0, you'll see that at this point, the function does not have derivative, or the function is not differentiable at that point. So in this observation, you'll see that the candidate for the maximum and minimum point is can be divided into 3 types. The first type is the endpoint of the interval at A at B, okay, and then the second and the third point will be the point where its derivative is 0, and we call this a stationary point. Okay? And then the third one is the point where the function fails to be differentiable at that point, and we call this the singular point. Okay? So now let us list the candidate of the maximum and minimum point. Okay. Okay. And okay. So the candidate of the extreme values is called the critical points. More precisely, we have the following theorem. Okay. So we have the following theorem. If okay, so always we consider the following assumption: f is continuous on the closed and bounded interval a comma b. Then if fc is an extreme value, okay, you may see that fc can be the minimum value, fc can be a maximum value. Okay, so let us abbreviate this. Let us see that this is an extreme value. Then, okay, the first conclusion, then one of the following conclusion holds for FC or for C. Okay, so the first one, okay, C is an endpoint C is an endpoint of the interval. Okay. In other words, C equals to A or C equals to B. Okay. The first conclusion. Okay, the first possible conclusion. The second one, C is a stationary point. The meaning is that f prime of C equals to 0. Okay? Or in a geometrical interpretation, the gradient of the tangent line to the curve at the point C comma FC is 0, since f prime of C is 0. So the tangent line to the curve is horizontal, or the tangent line to the curve is parallel to the x-axis. That's the second possibility. The third possibility, C is a singular point. C is a singular point. The meaning is that f is not differentiable at C. F is not differentiable at C. Okay, so that's the third possibility. Yeah. So let us repeat. Oops, I think I missed some page. Okay, let us repeat. Now assume that f is continuous on the interval a comma b. Then f is guaranteed to have maximum or minimum value. Okay, and then the location of the maximum and minimum value depends on the type of the function, of course. And then there are three possibilities. Okay, if fc is a maximum or minimum value, then there are three possibilities. The first one, c is an endpoint, so c is equal to a or equal to b. Okay, and then okay, I think I missed one page. The second possibility is c is a stationary point, namely f prime of c equals to 0. And then the third possibility, C is a singular point, namely f is not differentiable at C. Okay, so that's the third possibility. Okay, so to summarize this, then if you want to find finding the extreme value, of f on the closed and bounded interval a comma b, okay, the first thing to do is to check the continuity of f on the interval a comma b. Okay. Of course, if f is a polynomial or a sine or cosine function, then it's already guaranteed, because the polynomial or sine and also sine x or cosine of x is always continuous for every real number. Okay. So if your function is polynomial or sine x or cosine of x, then you may skip actually the first step. Yeah. Okay, and the second step, calculate FA and FB. Okay. It's easy because, okay, just simply calculate, because you have the formula of the function f, just replace the variable by A and B, then calculate it. Okay. And then the second one, check the derivative of f. Okay. The derivative of f, and if possible, find the solution to the equation f prime of x equals to 0. Okay. Okay, so just calculate the derivative of f and then find the solution to the equation f prime of x equals to 0. Okay, if you obtain, let's say f prime of c1 equals to 0, then this is the stationary point. Calculate fc1, let's say. Of course, the solution can be many. Some equations have more than one solution. For example, C1, C2, C1 prime, and so forth. The stationary point. But at the stationary point, please calculate the value of FC1 in this case. And then the third one, okay, if the function fails to be differentiable at the point, so find the singular point. Okay, find a singular point, or find any singular point. Of course, if your function is a polynomial or sine x or cosine of x, then there is no singular point. Just leave it. Okay. So if there is a singular point, if C2 is a singular point, then calculate C2. Calculate the singular. Calculate FC2. So and then after finding the endpoint, then stationary point and singular point, then compare the value of the function at this point. Okay. The next step will be compare the value of FA, FB, FC1, and FC2. Okay. So the largest value will be the maximum value. Will be the maximum value of the function f. The maximum value of f. The smallest point will be the minimum value. The smallest value will be the minimum value of f. That's it. Okay. So okay, I will summarize. The first step, calculate the value of the function at the endpoint. Okay. For example, the function is defined on the interval a comma b. Just calculate fa, just calculate fb, and then find the solution of f prime x equal to 0. Okay. Make sure that the solution is on the interval a comma b. Okay. If you can find, let's say the solution is c1, just calculate fc1, and then the next step, check whether the function has a singular point on the interval a comma b. Okay, so let's say if there is no, then just skip the step. Okay, so just compare fa, fb, and f at the stationary point. Okay, if the stationary, if the singular point exists, then also calculate the value of f at the singular point. Let's say c2. Then you can compare FA, FB, FC, FC1, and FC2. From these points, decide or choose which one is the largest one, and the largest one will be the maximum value, and the smallest one will be the minimum value. Okay, okay, so that's how we obtain the maximum and minimum value. Okay, so let us consider the example. Let us consider the example. For example, if I consider, let's say, the function is absolute value of x squared minus 1, for example. And then I want to consider the interval is -2 until 2, for example. Okay. minus 2 until 2. Okay, let us consider this function, but only on the interval minus 2 comma 2. Okay, and then the picture is given here, but now we focus on the interval minus 2 comma 2 only. So we only consider let's say this part of the curve. Okay, this part of this curve. Okay, you'll see that here. Okay, what is the first step? Okay, so I will write f of x here equals to absolute value of x squared minus 1. But now x is only on the interval minus 2 comma 2. Okay, only, for example. So in this case, what is the first step? Calculate f minus 2. F minus 2 equals to absolute value of minus 2 square minus 1. So that will be 3, right? The same applies for f2. F2 is also equals to 3. And then what is the next step? Find the derivative of this, where its derivative is 0. And actually, you can take a look at the graph of the function here. The meaning of the derivative of 0 is the gradient of the tangent line is 0. So in this case, you will have this point. Okay. Okay. Of course, okay, so if you want to find f prime of x equals to 0, then the solution is x equals to 0 here, right? X equals to 0. Okay, in this case, x equals to 0, and then you calculate f0. F0 equals to absolute value of 0 square minus 1, and that will be 1. Okay, that's the stationary point. And then can we find the singular point? If you take a look at the graph, the singular point is at minus 1 and 1, right? This is the singular point. Okay, the function fails to be differentiable at this point. And what is the value of the function at minus 1? The value is 0, and f1 is also 0. So you see that we should compare now f minus 2, f2, f0, f minus 1, and f1. So from this calculation, what is the largest value? The largest value is 3, right? So the maximum value is 3. The maximum value of the function is 3. Okay. So the maximum value is 3. So what is the minimum value? The minimum value is 0. So you'll see that here on the interval minus 2 comma 2, the maximum value of this function is 3, and the minimum value is 0. Okay. Any question or comment? Of course, you may consider another function, let's say polynomials as well. For example, x cubed minus 2x, for example. Okay, and then just concentrate. Okay, this is not so good. 3x squared, for example. Yes, any question? For example, in this case, I consider x cubed minus 3x plus 2, for example. And then I consider, let's say, the interval or plus 1. Okay. And then I consider the interval my interval is, let's say we consider the interval here. Okay. So f of x equals to this function x cubed minus 3x plus 1, for example. And then on the interval, let's say minus 2 comma, let's say 2 or 3 once again. Okay. Or I can, okay, just for the exercise, let's say the interval is 0 comma 3, for example. Okay, so the idea is that first we calculate f0. What is the value of f0? f0 equals to f0 equals to, in this case, equals to 1, right? Okay. Just substitute x by 0. f0 equals to 1. And then what is f3? 3 cubed minus 3 times 3 plus 1. So 27 minus 9 is 18, 19, right? Now, we have to find the solution of, okay, so you'll see that it's a polynomial. So the function does not have a singular point in this case, only have a stationary point. Okay. So in this case, we should find the solution of f prime of x equals to 0, right? So what is f prime of x in this case? F prime of x is 3x squared minus 3. So we have to find the solution of 3x squared minus 3 equals to 0. So x squared equals to 1. So of course, this equation has two solutions, x equals to 1 or x equals to minus 1. But here is the common mistake. We only work on the interval 0, 3. Okay. So the solution to this equation is only x equals to 1. We just ignore x equals to minus 1 because x equals to minus 1 is outside the interval. Okay, so that's the key point. Okay, of course, the solution is only x equals to 1. Okay, because x equals to minus 1 is outside of the interval. So in this case, we just calculate f1. Okay, f1 equals to, what is the value of f1? f1 equals to 1 minus 3 plus 1 is minus 1. Okay. So we have f0 equals to 1, f3 equals to 19, and f1 equals to minus 1. So what is the maximum value? The maximum value is? The maximum value is 19 because it's the largest one. The minimum value is? The minimum value is negative 1. Okay. Because if we put x equals to 1, we have 1 cubed minus 3 plus 1. So 2 minus 3 is minus 1. So the maximum value is 19 and the minimum value is minus 1. So that's the idea. So in this case, you will see that although the solution to the equation f prime of x equals to 0 is x equals to 1 or x equals to minus 1, but be careful, we do not include x equals to minus 1 because minus 1 is outside the interval 0, so be careful with this type of problem. The same applies for a singular point. If the singular point lies outside the interval, then you just ignore it. Okay? We do not calculate the value of f at that point. Okay? Just focus on the point at the end of the interval and inside the interval. Okay? So that's the candidate for the maximum value or the minimum value. Okay. All right. Is it clear up to this point? Okay. Is it clear? Okay. If that's the case, then we'll continue on the discussion about the monotonicity and concavity to find the to help us to find the maximum and the minimum value. Okay. Okay. So I will stop here and then we'll send